Java is a purely object-oriented language, except for primitive types, and it follows four main principles like encapsulation, abstraction, inheritance, and polymorphism. Java object-oriented programming system is a fundamental concept in Java that every developer must understand. So it allows a developer to structure code using classes and objects, and making it more modular, reusable, and scalable. The core idea of object-oriented programming system is to bind data and functions that operates on it, and preventing unauthorized access from other parts of code. So the Java strictly follows the don't repeat yourself principle, like by ensuring that common logic is written once and reused throughout the application. Here are the four pillars of object-oriented programming language. So that is encapsulation, which helps in wrapping data or a code in one unit, which helps in restricting the direct access to fields. And we have abstraction, which helps in hiding internal implementation, so only essential features. And we have inheritance, like one class acquires properties and methods of another class. At last, like we have polymorphism, like one action behaves differently based on a context. So we can achieve it with overloading and overriding concept. So, before going into concepts and its example, let's see what is class, objects, and constructor. So, basically, a class is a blueprint or a template for creating objects. It defines a variables and method that describes the behavior and state of an object. So, the syntax for creation of a class is it starts with a class keyword, and the user defined whatever the class name it can be. So basically we have some naming conventions, so which I already discussed in previous video. So let's say if you have two words, um, both the first word of first letter and the second word first letter should be caps, and the fields and methods, that variables and methods will be enclosed within flower brackets. So this is the syntax. An object. So object is a real instance of class. It is created using a new keyword, and it has its own memory and access to method and fields of the class. So here we have a class. To create it, to create the object of this class, what we do is like we use the same class name, and we can have a object reference or the variable for the class we are creating, and a new keyword, and again the same class name and open and close bracket. So this is how we create a object. Here's a simple example. Here I have a class which follows the syntax here, which contains a class keyword, and this class name is student. It has both a variable and a methods. I have id, which is int, and name, which is string, and the display method will display the fields value. To create an object for this class, what we are doing is the same syntax we are following. The student, that is a class name, and the variable name, then a new keyword which says we are creating the object, then the class name. To access fields individually, what we do is we use a reference, like a variable as a reference, use dot operator to get the required variable. So id and name can be retrieved, or to assign the value, the same thing can be achieved. Like if you want to assign a value to any variable, use the same thing. And to display the value, you can use means here I'm using method to display the variable's value. So instead of initializing um, a variable um, separately, we can use a constructor. So a constructor is a special method that gets called when object is created. So it is used to initialize the object. So there are some rules, like constructor should be same name as the class, and it should not contain any return type, and can be default, that is without parameter, and or can have parameter as well. So if you have not defined any constructor, compiler will create a default a constructor itself. So in this case, a compiler will create a default constructor with the same name, and it won't have anything. It's like just a placeholder kind of thing. So here is a simple example, the same student class I have, but with that I have a constructor as well. You can see a default constructor. If we have not used this, or if you have not created this, compiler will have a same um, constructor without statements. Here I have a statement just to say it's a default constructor. Then I have a parameterized constructor which has a parameters like same as what the class has. So whenever I create an object of this class, here means I have two approach. One is just creating an object and adding value separately. Here with the creation of object itself, we can assign values to the variables. So both give the same output, but you can see instead of having multiple lines, we can achieve it in a single line. So we can use this keyword as super keyword and all. Those things we'll discuss in coming videos. Those are all belongs to a constructor for chaining, constructor chaining and all. So there are different types of constructor. That is a default constructor without a parameter created by compiler if we have not defined. Then we have parameterized, which takes argument to initialize the objects fields. Then copy constructor, it's not a built-in like C++, but can be manually defined. So now we can see the each principles of object-oriented programming system in Java. So first is encapsulation. So encapsulation means wrapping the variables and methods together in a single unit, that is a single class. So it also hides internal details from outside access. So basically, encapsulation can be achieved by declaring variables in class as a private and providing those access via public methods. So here you can see I have used private fields and public methods. So private fields in the sense we have access specifier which specify the access to a fields or variable and a method as well. So if you assign or if you create any variable or method with a private keyword, so it will be accessed only within the class and we can't access it from outside the class. And if it is public, we can access for it from anywhere. So you can see here we are binding the data here, all the methods and fields in within the class, and we are hiding a variable, so you can't access the variable of this class from outside. To access this, what we are doing is we have a public methods. So if you want to assign value, what we do is like we have a setter method to set the value. We have a get method to get the value. So this is how like in a real world, if you are creating a project, there will be a model project. So within that, we'll have the classes to create a model for all your projects. So like our database models, if you are creating any um, or if you are assigning any value to the database, there will be a model for each tables, so that like id, name, first name, last name, whatever it is. So instead of assigning value manually, what we do is like we just call this class encapsulating. So that's the use of encapsulation, wrapping all the fields and methods within a single class. So then we have abstraction. So abstraction means hiding unnecessary implementation details and showing only the essential features. So this we can achieve through abstract class and interfaces. So here is the abstract class. The class becomes abstract when we have a abstract keyword. So here you can see it's an abstract method. It doesn't contain anything. So it's just an method without any implementations or no statements. So that implementation we will do in other class by extending it. So we are using extend keyword. This is like inheritance concept. So we are extending the abstract class so that we can use or we can override the uh, features of those class. So here I'm using a sound method of a parent class. I'm just having the statements here. This is how we achieve Abstraction. So through abstract class, we can't achieve 100% abstraction. So for that, we have a interface. So an interface in Java is a contract that defines a set of abstract methods and fields. So that class can must implement. So it is used to achieve abstraction, that is 100% abstraction and multiple inheritance. So why we use interface? So for abstraction, and multiple inheritance and close coupling. So which helps in designing flexible plugin architecture. So instead of having a keyword abstract and class, we can directly use interface keyword, and we can name the interface name. It's similar to a class. Instead of class, we have interface. Instead of class name, we have interface name. Then we'll have empty methods without any implementations. So we can implement those things using other method by inheriting this interface. Here's a simple example. I have an interface class here called animal and has methods like sound and eat. I'm implementing this interface using implement keyword. If we are inheriting, like, we can use extend. So here I'm implementing interface. If you are inheriting class, we have to use keyword extend, and if you are inheriting interface, we have to use implements keyword. Here you can see I have as I have inherited animal class or animal interface. So I have both the method sound and eat, and which has some implementation is just an print statement like dog barks and dog eats bones. So whenever I use this interface, you can see with the interface, and I have a, a class called dog, and I'm using the object to call the sound and eat methods, which will give a output as sound barks and dog eats, sorry, dogs barks and dog eat bones. So in real world, we have a interface as a list, set and all. So there are a list interface, set interface or map interface, and we have a class called array list, linked list and all, which inherit a list interface. In real world, that's how we use abstraction and oops concept in Java. So then we have inheritance. So inheritance is the process where one class acquires the property and behavior of another class. Here we have seen already that we are using other interface in child class. Here it's the interface animal is the parent and dog is the child. So we are implementing all the methods of a parent class. If we are going with class approach, here you can see we have a class called vehicle, and it has a method start. So don't confuse with class and interface. Interface won't have any implementation. Class will have implementation, and you can see I have a start a method within the class. It says like vehicle started. Then I have another class which extends or which inherits the parent class vehicle, and it has a horn method which says car horn. So whenever I create this object, we can get the output like car horn and vehicle started as well. So this is about inheritance in Java. So next comes a polymorphism, which means many forms. The same method behaves differently depending upon object. So this we can achieve using method overloading, which is a compile time polymorphism, and we have a method overriding, which is a runtime polymorphism. So a method overloading means defining multiple methods in the same class with same name but different parameters. And method overriding is means a subclass providing a specific implementation of a method that is already defined in its superclass. Means within the class it will be method overloading, and within other classes it will be overriding. So here is the example. So Java decides which methods to call based on its number of parameters, type of parameters, and order of parameters. So that is, here you can see I have a math util class with two methods with same name, that is add. But a parameter, if you see, I have two parameters, that is int, and in another method I have two parameter, that is double. Again, the return type is int and double here, and you can see the operation what we are doing is I'm just adding the two parameters, but in one case it is int and another case is double. So based on the passed value, Java will decide which one to call. So if I am creating an object like a math utils and calling a method add with passing two int, it will call this method, and it will, if I'm passing a parameters a double, it will call this method. So based on the parameters and its types and order, Java will decide which one to call. So then I have or then we have a method overriding. So as I mentioned, like different classes having same methods. So it must be inherited. Like you have to, if you want to go with overriding, you have to inherit the parent class, and a method name, parameters, and return type must match exactly. So if you see here, the both the method has the same return type, parameters there is no parameters, and a return type as well. And it happens at runtime. That's why it called as runtime polymorphism. And usually IDE by default, what it do is it will add the annotation override. So here is an example. Um, in case of overriding, we need to have two classes. The child class here is cat is a child class which inherit the animal things, like we are using extend keyword to inherit the class animal. Then I have both same methods, that is meow and animal sound. So at last, there is a concept called relationship. So we have is a relationship, and we have has a relationship, that is like it represents, like is a relationship represent a inheritance when one class extends another, and it used to express that the subclass is a type of its superclass. So that is the syntax. You can see here, I have a class animal and I have a class dog which extends the animal, and this is means dog is a animal, means is a relationship animal, means here we are using is a relationship. So the previous example also we have used is a relationship, that whenever you inherit as inheritance or inherit any class, it will be an inherit or is a relationship. When you go with has a relationship, like when you consider has a relationship, it's an relationship which represents a composition when one class contains a reference of another class as a member variable. So if you are creating any objects of another class within means object, if you are creating object of another class within the class, you can say it has a relationship. You can see I have a class called engine and I have a class called car. So inside the car, I have created a object of engine, and I can say that car has a engine. So instead of inheriting, what I'm doing is I'm just using has a relationship concept. That is, I'm creating an object within other class. So what I can say is like car has a engine relationship. That's it. So here's a small example. Like I can see I have a run method for engine class, and within another class called car, I have created an object of engine class, using again the syntax of object creation. Then within the car class, I have a start method which calls the run method of engine. Then another statement just to print car started. So whenever I call the start method by creating car object, it will print engine running and car started. Like as it has both the methods to call the run method of engine, and I'm just printing the message within car class. So overall, to summarize, we have a four pillar within Java OOPS concept, that is encapsulation, which helps in protecting and hiding the data, and abstraction, again hiding complexity and show only essential, which can be achieved using abstract class or interface. Then re-inheritance, to use reuse the fields and methods by using extend keyword. Then we have a polymorphism, one interface, multiple behaviors. So let's see a simple example here. I have a simple example which I have used all the required concepts, that is abstraction, inheritance, encapsulation, and polymorphism. So this example is for a banking system, that is whenever you uh, deposit something, the value will be added, or deposit amount will be added to the existing amount, and to get the current amount details. So it's a simple one. So here you can see what you want. Basically, you want a account class, and to maintain the transaction, one class, that is abstract class for account handling. So you can see here, I have a class called savings account, and which extends the account class. So within account, we'll see what are the things we have. It's an abstract class which has a private fields, that is account holder and a balance. So here's account holder name, which is string, and the balance, that is a double. So both are private. So it's again, this is encapsulation process. Both are private. So how to access these things? So to access these things, we have a getter method called a get method, and I have used a constructor which will help to set the value. So which has a same name, and the parameters are name and initial balance, that is a balance. Then I have a abstract method to deposit, which will be overridden in the child class. Here the same deposit, here you can see, which has no implementation, but here I have some implementation. We'll see that later. Then again, within that, we have a display account info, a method which just display the info. Then we have a protected method, that is update a balance. So then I am extending this abstract class. So you can see savings account. So whenever I create this object, so I will be having super keyword which will call the parent constructor. So to call a parent constructor, we can use a super keyword, and if you want to call constructors within the class, we can use this. So those things we'll see in the next videos. So here, whenever I create a saving account object, we have to, or if we pass a name and means the account name and the balance, it will initialize those values. Then the deposit method, which override from the parent class, which has implementation like update balance and show the message saying amount is deposited. So how to use those things? So here you can see I have created an object called using saving object, or using the syntax of a class name, and the variable for the object is ACC. I'm passing initial value. So alias is the account name and initial amount is 1000. So first let's display the method, then deposit the amount. So then lastly show that updated balance using get balance method. Again, this get balance is a getter method which helps to get the balance of an account. Here is an output. You can see account holder is ls. Like as soon as I create the object, and if I print, or if I call the display account info, what it does is it says account holder is a holder, then balance in cell balance, then deposit a 500. So deposit 500 is checking whether amount is greater than 0. If it is, then update the balance. So you can see here I have a protected method which adds amount with a balance, then deposit the proposed amount, that is 500 is like deposited into saving account. Then update balance using getter method. I'm just getting the updated balance. The final amount is 1500. So this is a simple example to show you the oops concept in Java. Thanks for watching.